Bob Crippen mentioned that he had a superb vehicle and he plans to bring it back in exactly the same condition. 30 seconds away from picking up the countdown and proceeding towards launch of 41-C, the first mission to go out, capture a satellite in orbit, repair it, and place it back. About 15 seconds away from picking up the countdown. The NASA test director counting down to picking up the count once again, and T-minus 9 minutes and counting. The launch events are now being controlled by the ground launch sequencer from now up until the T-minus 25-second point, when we'll switch to the onboard redundant set launch sequencer. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the orbiter's onboard computers, which then report back to the launch processing system that the commands have been executed. Earlier in the countdown, the NASA test director and launch director were commenting on the smoothness of the countdown and commented that that's what we had the ground launch sequencer and the launch processing system for. The primary job of the computers on board is to check that all the launch commit criteria, such as propellant loads, temperatures, pressures, and other requirements, are proper. T-minus 8 minutes and counting. Everything proceeding smoothly toward an on-time liftoff of 8:58.
OTC flight, SBC load is complete. Copy that, thank you.
Up in 30 seconds. At that particular point, the crew access arm will start retracting. And we have the crew access arm beginning its retracting from the orbiter. If an emergency should arise, the tower can be put back into position within 15 seconds. Houston is sending a final update to the onboard computer for antenna management, and the AC electrical bus sensors have been placed in monitor by pilot Dick Scobie. T-minus 7 minutes and counting, everything going smoothly. T-minus 6 minutes, 35 seconds and counting. Pilot Dick Scobie is performing the auxiliary power unit pre-start, which consists of positioning a number of switches and verifying that they are in the proper position. Coming up on the 6-minute point in our countdown. T-minus 5 minutes, 57 seconds and counting. And Dick Scobie reports the APUs are now configured for startup. T-minus 5 minutes, 30 seconds and counting. The flight recorders are on. These flight recorders provide measurements of shuttle system performance during the entire mission for playback after landing. At the 5-minute point, we'll get a go for APU start. The APUs, or auxiliary power units, are used to provide hydraulic power to the aerosurfaces and engines for steering. T-minus 5 minutes and counting. And we have a go for APU start. The heater reconfiguration is complete. and APU start is complete. The liquid oxygen fill and drain valve in the external tank has been closed and topping of the tank completed. Pilot Dick Scobie reporting that all 3 of the APUs, or auxiliary power units, are up and running. The liquid oxygen drain back has been started. This means that liquid oxygen is flowing through the main propulsion system and back to the large storage tank to cool the system slowly down to 270 degrees below zero so that they'll not be shocked by the torrent of super cold fluid at the time of engine ignition, just past the 4-minute point in the countdown. And the firing circuit for the solid rocket booster ignition and range safety destruct devices has been armed by the ground launch sequencer commands. T-minus 3 minutes, 40 seconds, and counting. The Elevon speed brakes and rudder are now being moved through a pre-programmed pattern to ensure that they're capable of doing their job during the flight. The shuttle is now on internal power. However, the fuel cells are still receiving their fuels from the ground support equipment for another minute. Coming up on the 3-minute point in our countdown, the engine gimbal or movement check of the main engines is underway to ensure they're ready to control the flight. And T-minus 3 minutes and counting. T-minus 2 minutes, 55 seconds and counting. The profile of both the engine gimbals and the aero surfaces was satisfactory. The liquid oxygen valve for filling the external tank is closed and pressurization has begun. The gaseous oxygen vent arm being retracted at T-minus 2 minutes, 30 seconds and counting. And the fuel cell ground supply of oxygen and hydrogen has been terminated, the vehicle now using its onboard supply. T-minus 2 minutes, 15 seconds, and the main engines have been moved to start position, and the astronauts have cleared the caution and warning memories of their onboard computers. T-minus 2 minutes and counting. The liquid hydrogen vent valve has been closed and flight pressurization underway. T-minus 1 minute, 45 seconds. The computer will automatically verify the readiness of the main engine at T-minus 1 minute. T-minus 1 minute, 30 seconds and counting. Everything going smoothly as we look forward to liftoff of 41-C. T-minus 1 minute, 15 seconds. The liquid hydrogen tank at flight pressure. Coming up on the 1 minute point in our countdown. T-minus 1 minute and counting. The firing system for the sound suppression water system is armed. The hydrogen igniters under the orbiter's engines have been armed. These devices assure that any hydrogen flowing through the engines does not accumulate. T-minus 45 seconds, just 14 seconds away from switching command of the countdown to the onboard computers. T-minus 35 seconds, the GOX vent arm fully retracted, and we're switching command to the onboard computers. The SRB hydraulic power units have started. T-minus 20 seconds. T-minus 17, 16, 15, 13, 12, 11, 10. We are go for main engine start. 8, 7, 6. We have main engine start. 3, 2, 1. Solid motor ignition and liftoff. Liftoff of Challenger and the first flight to repair a satellite in space. We have cleared the tower.
All throttles back.
Houston, go at throttle up.
All throttles back up to 104% rated thrust. Altitude 10.5 nautical miles, velocity 3,200 feet per second, distance downrange 7 nautical miles. Engine performance continues nominal. APU speeds, temperatures, and pressures all look good. Velocity 4,000 feet per second. Altitude 16 nautical miles, distance downrange 11 nautical miles. Standing by for chamber pressure call, which will be the precursor of solid motor separation.
Roger. Roger, separation. Looks good.
Nominal separation of the solid rocket motors. Guidance has converged as planned, and main engine performance still looks good. First stage performance called out as being low.
Houston, first stage performance low. Roger, low first stage.
That call indicating to the crew that subsequent calls may be a little bit later than initially programmed. Main engine performance still nominal. Pressures, temperatures are well within nominal constraints.
Challenger Houston, 2-engine TAL capability. Roger, TAL.
That call advising the crew that if one main engine should fail, the Challenger can still make its transatlantic abort site to Dakar, at Senegal, on the west coast of Africa. Engine performance still flawless. APU pressures, temperatures, and speeds are right on the mark. Challenger on course and on time. Flight Director Gary Cohen getting a status report from all positions in the mission control room. All console positions report go. Challenger on course and on time. Velocity 7,000 feet per second. Altitude 54 nautical miles. Distance downrange 90